Hope you've had an interesting black hat, and I know that right now is basically the last session, so we'll try to keep it short, sweet, to the point, and then do some Q&A on whatever it is that you folks are interested in talking about. My name is Jason Garms. I'm a lead program manager in the Windows NT development organization at Microsoft, and I'm part of an organization actually within the development organization that does security design reviews of all non-security components within the Windows operating system. And last year, some colleagues of mine, we've been talking about this for about 3 years, but last year we finally got our act together and decided it's about time that we put a beta version of some of our software on the internet and actually invited people to come and try to break into it and see what happened and so forth. I mean, we'd always worked under the perception that, by the time we did this last year, there had been over 1 million copies, beta copies of Windows 2000 already distributed. And part of what we assumed is that, there's plenty of versions of Windows 2000 out there in the world that people can play with and do stuff with, and, why should we just go put yet one more copy up? But we spent some time thinking about that, and we talked with a number of different people and with customers and some people who might be in the audience today but who are definitely here at Black Hat speaking, encouraged us to go ahead and do this, so we did it. We'll talk about during this session exactly what we did, what happened while we did it, and where we're going to go from here. So our whole goal is to ship more secure products. It's not to patch products after they ship. It's not to do anything else. It's to ship the best products that we possibly can. That's why we wake up in the morning. That's why each and every one of us that works in our organization goes to work. What we wanted to do was to try to complement the beta testing and really try to take advantage of some of the real-world creativity that's out there in various places in the world, and also to be able to capture some of the people that may not otherwise have access to these kinds of systems. We had a number of Unix people who would come and say, hey, look, I don't want to run your software on our systems, but I really want to attack it. And so we said, well, we want your creativity, so sure. So we put the machine up and invited those attacks. We also wanted to be able to take and document exactly what we did in building that site, and be able to then provide better information for people about how to secure their sites. We had done a number of things up to that point in terms of configuration guidelines, but there still is a lot of room for improvement there, and we wanted to contribute to that. So what we actually ended up building was a site on the internet, and we'll go through in some degree of gory detail exactly what it was, but a site on the internet where we put a sample guest book application that people could come. It was a dynamic application with a back-end database, and people could come and they could post comments into the guest book and view a status of exactly what's happening on the site, view some other information on that site, and in general twiddle with that machine to their heart's content. As I said, every day we kept logs about what was going on that site. My colleagues who were working on this project last year announced what was happening with that site, if we were taking it up, if we were putting it down, if we're installing new builds, daily builds of the operating system onto the machine, what happened for crashes, why it crashed, if it did crash, and so forth. And we tried to create some basic ground rules. We're, again, trying to find out what people can do to these systems. And we wanted to leverage creativity. So the ground rules, as we enumerated them on the site, were make it interesting. Do whatever you want to be able to do against this particular box or this system that we have installed here. Try things that you've never tried before or never had machines in which to try it against. Try to compromise an account. Try to guess a password. Try to figure out some way to getting around those accounts and so forth. Try to change something that you shouldn't have the ability to change, like the main page on that site. Try to gain access to something you shouldn't have been able to get access to. So we had information, for example, the ASP source code that we used on that site. If you could gain access to that ASP source code, that would be an example of gaining access to something that we didn't want you to gain access to by the rules of the site. And we were going to do our darn best within a certain set of constraints to protect the system against those attacks. We also made it clear that this was a test server, and that because it was a test server, there were two very important things. Number one is we weren't inviting wholesale mayhem and attacks on the world. You know, as unfortunate as it is, the IP protocol that binds the internet is, if we had it to do all over again today, maybe not the way that everyone would design it. And so going and attacking downstream routers 5 and 6 hops away from us was not what we were asking you to do. And it certainly didn't serve any purpose. And secondly, because this was a test server, we were operating on a different set of guidelines from what you would probably do in a production environment. For example, if the site went down, we would keep it down for as long as it took to figure out what was going on. We didn't have uptime guidelines that said, oh, we're going to get it back up as fast as we can. And so that made a difference in exactly how we went about executing on the site. And then we provided an email account, and we said, if you find exploits, send them to us, and we'll make sure that they're addressed. And of course, we're doing a lot of monitoring as well to make sure that we knew before you even emailed us that something had happened. Now, I've gotten a lot of questions in the past about, well, you know, Microsoft, you know, why don't you give us money for doing this, or why don't you reward people and so forth. And, you know, if it were completely up to me, you know, we would certainly provide rewards for people who were able to compromise the site. There was a couple of problems, and we went to legal originally, to our legal counsel, and talked to them about putting this site up. Of course, you know, there were all kinds of red flags about what happens. And the prize, the whole concept of prizing was one of the toughest ones that we faced, because I learned a lot more about the legal ramifications of awarding prizes than I ever cared to know in my entire life. But apparently there's different laws in every single country about how prizes can be awarded through contests, and these laws actually fall under the gambling laws of most countries. And so in order to legally do this kind of a challenge and offer prizes, because the reality is we know that most of these attacks aren't going to come from the US, and a lot of the creative attacks are going to come from other countries, perhaps not in the US or Western Europe or Canada and so forth. And we would have to build legal contracts in every single country where somebody might possibly attack from. And if we didn't prepare them, we found out that we could actually get in trouble with the countries that we've awarded, you know, prizes to people that live in those countries. So it was just absolute mayhem from that point of view. And we're going to take a look at that again when we do a round 2 version of this. So, you know, keep your eyes posted. But it's a legal hurdle if you actually want to do it right. A lot of people just kind of ignore the legalities of things, and unfortunately, when you're in our position, you can't do that. So briefly, a little bit about the site statistics. We went live on the 3rd of August last year, so it's actually almost a year ago, and we operated for almost 90 days. We closed down on the 27th of October. Pretty interesting statistics. We had over 10 million hits to that site over that 3-month period, and even more impressive when you realize, as we go through this, that we only had a T1 connecting that site. We had over 400 simultaneous users for a good part of the first month. That was people that were browsing the website that we counted as users, or sessions against the FTP server that we'll talk about later. And we had over 500,000 attacks against that site. This one poor little lone machine on the end of a T1 line. And that's attacks as measured by the IS the Real Secure product that we had sitting on the net watching for attacks, and we'll talk about that later as well. We generated over 10 gigabytes of HTTP logs just from this one site, with a very few number of ASP pages and a couple of static HTML pages. 10 gigabytes of logs just for that over the 3-month period. And we kept every one of those. In fact, I still have them today. And we generated over 8 gigabytes of netmon logs every day, and we backed those up every day to a DLT tape device, so we could go and look at them later if we thought we had missed something. Now, if you do the math, and I may have done it wrong quickly, but if you do the math, I think on a T1 line you get a maximum data throughput if you saturate it of 24 gigabytes a day. And so we were seeing about a third saturation if you averaged out over the day, over the week, over the 3-month period. So that's an awful lot of traffic. to kind of preempt the rest of the presentation so we can all go home, the net results was everything was fine. Well, that's kind of glossing over it a little bit. Then the good news is that no data was compromised. Nobody broke into an account. Nobody's able to steal files that they shouldn't have access to. Nobody's able to place files onto the system or data onto the system they shouldn't have been able to. Now, with that said, we had some interesting activities that we'll talk about through this session. The first thing that people tried to do when we put this site up was to go after this the guest book application, which we had written, only with the intent of having something on that site that people would look at, not to test the security of the guest book application, but we had a simple bad word filter on it that filtered out, your common four-letter words and stuff, and so people decided to expend their creativity on trying to figure out how to get around the guest book filter and how to post all kinds of things to the site, and we had a little rule in the site that said you can only post one comment per IP address per day. So of course we had tons of people spoofing their IP addresses just so they could post lots and lots and lots of comments, and so that's what people spent a good amount of the beginning of the site doing, and they found some basic parsing problems in this guest book application that my colleague had written that would allow them to put really long strings in that they shouldn't have had. These aren't overflows or anything else. But then when you went and viewed the guest book application, weird things would happen to your browser. You'd say, well, where's the page? And it's because it's way off on the right side of the page and things like that. So that was a fun little nuisance, and we just fixed the ASP code and made the filter work better. Then, as soon as people realized that, well, gosh, there's a lot of places in the world that we could post stupid little comments to, we started getting a lot of IP fragmentation attacks. In fact, the IP fragmentation attacks basically saturated the network for quite a while. And again, this is just a simple little T1 pipe coming in, and we had people with T1 and greater pipes all around the world just pumping fragmented IP packets down our throats, which, while it didn't hurt the site itself, it provided incredible performance problems in terms of people trying to retrieve valid HTTP pages. And then shortly after the IP fragmentation stuff, everything that you can possibly think of, people threw at us, and we'll talk about what some of those are. But the net result is we actually did find some bugs, and we fixed those bugs before shipping the product, and we'll touch on what some of those were. So from a site architecture point of view, we actually went through 3 phases. In my mind, I think of it as 2, but it's really 3 phases. We started off with a single IIS box and running SQL Server on that box, and that box was effectively doing everything on the site. And shortly thereafter, we actually took that SQL Server and put it into a back-end box, and I'll show you a little map of that in a slide or two, so you can get a better feel. But because this is how people really run their systems. Excuse me. When you have a network-attached web server, it's not very commonplace that you run your database server on that box. So again, we're trying to mimic something that was reasonably real-world scenario. And then the third phase in our site topology was we added a second IIS box. So we were actually effectively balancing between the 2 IIS boxes, and then we introduced additional protocols, and we'll talk about exactly what happened there. Now, one of the important points that will help explain some of what happens later in the presentation is that this was not managed by a real IT organization. This is managed by a couple of developer heads in our organization who had never managed a real professional site before, didn't really know what a UPS was, didn't really care about RAID arrays, didn't really care about any of those other things. And so we have some, and everything was run on desktop class boxes. So it ended up for some interesting results. So the goals in Site 1, Rev 1 and 2, Rev 2 followed very quickly into Rev 1, was just get it up and running. Put something there that resembled in some close capacity what an actual customer would deploy in terms of a web server serving active content from a database and interacting with that database. And that was the simplest goal. It wasn't to put up a lot of additional ports and a lot of other information. And so that impacted some of what we initially did. So from a site topology point of view, I'll read what the labels are here for people further in the back. We're starting down in the bottom left-hand corner. We have the ISP cloud that came in and communicated over T1 to a Cisco router effectively. And what we have here is the stuff above the dotted line is what we had on-premise in our test site, and what was below the line is actually what was off-premise on the ISP site, equipment that we had no control over. And so this is, again, what happens in the real world. We effectively got a 10 base T outlet into the office where the test stuff was occurring. That 10 base T or 100 base T jack went into a hub. The hub plugged into, there's 3 devices plugged into it. Starting on the left was an IS Real Secure box. We were just doing that for monitoring. We were just curious to see what Real Secure would say in terms of the number of attacks we got. That's how we got that 500,000 total attacks. It was just from watching what Real Secure said. The second box to that is a Netmon box. We effectively had just a basic version of NT. We unbound all protocols from that box, and then we listened on Netmon. The reason we unbound all protocols is it makes it much harder to try to attack the Netmon box. It also makes it very difficult to actually detect that the Netmon box is there. You certainly can't attack it in terms of addressing because it has no IP address. The big machine in the middle is the IIS box. That was the web server that we were running, which actually was a dual-home device. So the front end was plugged into effectively the public network. The back end was plugged into a back private network, the backbone of which is represented on the top of the slide as a 100 base T hub. This again mirrors very closely the way that people would deploy these in real life. It communicated over that back end to a SQL server, which is also running Windows 2000, regular daily builds of Windows 2000, and SQL Server 7 database. Over a serial interface, we had a debugger plugged into, we had a debugger plugged into the IS box. There's actually a debugger plugged into the SQL Server box as well. And this would enable us to really be able to figure out what happened if something happened to those boxes. So the web server was a standard desktop style box. It's a high-end desktop with SCSI interfaces. It's 500 megahertz Pentium 3, a quarter gig of RAM. Other than that, there's nothing special about that box. We were doing absolutely no port filtering on any of the interfaces on the ISP side of things. And that becomes very important as we talk a little bit further. What we did do is we used functionality in Windows 2000 called IPsec port filtering, which we'll talk about on the next slide, to actually provide very complicated or very advanced port filtering capabilities similar to TCP port wrapper or port wrapper type software on Unix boxes. And we communicate over the back-end interfaces using sockets. The default's named pipes, but we just thought it'd be more interesting for people to do sockets because it's not quite as robust. So we did sockets communication over port 1433. Now, one of the most important things that I probably have to say today, and if people walk out of here with nothing else, it's that you should look into IPsec port filtering in Windows 2000 if you're running Windows 2000 anywhere in your environment. IPsec port filtering is not to be confused with IPsec VPN. The IPsec port filtering was accidentally built, I guess you could say, as part of our VPN solution. So as we were building IPsec VPN technologies, one of the things you needed to be able to do was very granular, very robust port filtering. And the reality is you can use that port filtering without using any other part of the IPsec functionality. No IPsec AH authenticated header stuff, no IPsec data payload encryption, no IPsec tunneling, forget about all that stuff. You can just run IPsec port filtering and you can lock down just the ports that you want in just the configurations that you want. So again, you can liken this very much to TCP wrapper style functionality. And so there's a great command line utility in the resource kit called IPsec POL, which lets you define these very elegantly. And what I have up here are the 4 commands that we use to configure this device. And effectively what they do is the first command here, and I know that some people in the back can't read it, so I won't expect you to, but the first command effectively says, we're going to create a new policy called my web policy. The second command says, we're going to deny all traffic to this site of all types. Deny it completely. The third one says we're going to explicitly permit anything addressed to my local IP address adapter in both directions addressed to port 80, and we're going to call that the HTTP or the OK HTTP rule, and we're going to add that to our web policy. And then the final one is that we're going to create another rule called OK ICMP, which we're going to allow bidirectional ICMP communication to our local interface. And again, we chose this because we're just a web server. We don't need to do anything but serve web. And we just thought it'd be nice to leave some ICMP stuff so people could actually find out a little bit more about our site. And that's all that was there. Now, the way the IPsec port filter works is it works from filter of most specificity to filter of least specificity. So since we said deny all in the first rule, but it was a very global generic thing, and then we specifically said, but for this one port, permit stuff through, and then on the final rule we said, and for this other protocol, ICMP, permit these through. Those took specificity or priority over the deny all. So you can use this for configuring and locking down any Windows 2000 boxes that you run anywhere in your environment, including within your intranet. And this is really an incredibly powerful tool that you can use. So when we moved to Rev 3 of our site, we upgraded the boxes to Windows 2000 Advanced Server simply because we wanted to give some additional coverage for the Advanced Server version of the product. And we added the Active Directory. Again, Active Directory was an important technology. It seemed like a reasonable thing to add Active Directory to this. And we opened up a bunch of additional ports and interfaces and had stuff running on them. We opened up LDAP and LDAP over SSL so people could actually try to do directory queries against us and try to break into the directory. We opened up FTP so you could connect to us and try to do some creative things, brute force passwords through FTP, do some other interesting things. We opened up Telnet. Same reason. We opened up SSL, so we started serving SSL content to people, and we opened up the CIFS port as well, so you could attempt to do CIFS file sharing attacks against us as well. And so this is effectively the map. You'll notice that the major difference is that we have a second box there on the right. But other than that, very similar. We upgraded the hardware from 500 to 600 megahertz boxes, no real difference. And we use a dual proc 600 megahertz box for the SSL box. Again, SSL is a performance eater, we all know that, so we gave it a little extra horsepower just for that. And these are the ports that we actually permitted, and I'll read them out because I know many of you can't read it from there. 20 and 21 for FTP, 23 for Telnet, 80 for HTTP, 88 for Kerberos, 443 for HTTP SSL, 445 for SMB, 500 for ISA-KMP, which is the key exchange protocol for IPsec. So if you actually wanted to try to attack our IPsec implementation, you could actually attack that service as well as ports 389 and 636, which are the LDAP and LDAP over SSL ports respectively. So we opened those up on the filters. Now, one of the interesting things that happened is, as I mentioned, we ran debuggers on all these machines. And the way, I'm not sure, I assume probably many of you are familiar with development environments, but some people may not be with developing OSs. But effectively, we have a lot of breakpoints in the code that if a debugger is attached and you reach this assertion breakpoint, which says, if X doesn't equal Y, assert and drop the box into a debugger. So this kind of code would get executed if you have a debugger attached. What that meant is that things that would normally be slow memory leaks, perhaps they would take 2, 3, 4 months, maybe, or maybe weeks, or maybe days, whatever, to take down a box normally, failed in our case immediately as soon as you reach that condition because the assert failed. And that's what we were trying to do. We wanted to find these kinds of conditions where bad things were happening, and so we actually had more asserts than some of the code that we were interested in looking for that would drop the machine into a debugger, effectively resulting in a denial of service. But we didn't really care. We wanted to find the bugs. And we might leave that machine sitting in the debugger for hours. I don't think it ever lasted longer than hours, but for hours until we got the developer from another floor, from another building, to come over and fix their code that was causing that machine to sit in that debugger. The initial reaction to this site was actually quite interesting. There was a number of fun things that happened. When you ran Nmap against it, it thought it was a Linux box. There were a couple of reasons for that, one of which is we dramatically changed the way that we do TCP sequence number generation in Windows 2000. We'd had probably a lot of people in this room, and certainly a number of people at this conference who spoke at this conference, tell us in the past that they don't believe that our TCP sequence generation was random enough. It certainly was not as random as other platforms. So we fixed that. We said, okay, in Windows 2000 it's going to be random. And Nmap thought it was just as random as the Linux box, and that we had some other characteristics, including ports that they expected to be open on a Windows box that were not open. And so they said, oh, it's a Linux box, which was a good giggle. And the second issue is that people swore up and down, that there was a firewall. Because we said publicly, there is no firewall on this box. There's IPsec port filtering, but there is no firewall. People swore up and down that there is no firewall. There is a firewall. There is a firewall. You're lying. You can always go and you can prove it by just putting on IPsec port filtering on your box, and you'll find out that nothing responds. Because when IPsec port filter accepts, when it receives a packet, if it's doesn't fit one of the rules, it just drops it. And that's what a lot of firewalls do. So it was quite interesting from a reaction point of view. Now, the machine configurations become very important too, because this is really where the lessons learned become important, where we can improve either the default parts of the product or create better documentation that people can actually, reproduce this themselves. So we say, well, you had a successful box, it didn't get broken into. How do I do that myself? And so, this was effectively the recipe. It was very easy. We did a default installation of Windows 2000 on NTFS. We just put the CD in, booted from the CD, installed it. Then we used a document that my colleague Mike Howard created on the web called the Internet Information Server Checklist, which is built for IS4, and of course we're running IS5. But we used that as far as it was applicable to the configuration. We turned on IPsec port filtering. We went and we explicitly turned on auditing on files that we knew people shouldn't be hitting, so we could actually go and watch those files. When we installed the Active Directory, we installed it with default sets of ACLs on all objects in the directory. We created a few accounts. We didn't put a firewall. We used no host-based intrusion detection. And we took offline, we took MD5 checksums of all of the interesting files on the machine, and we kept those offline. We actually used Jazz disks on these boxes, which is not what you'd probably do in a high-end production box, but for the needs that we had there, it was very useful. We took the Jazz disks, we had the machine built, all the sensitive files that we were dealing with were on the Jazz disk. We took the Jazz disk out of the internet-connected machine, took it to a trusted workstation, put it in the trusted workstation, did MD5 checksums on all of those files, left them on the trusted workstation, took the Jazz disk, put it back into the internet site, and if we wanted to do a compare at a later date, we would use that same procedure, again, making sure that we knew what was trusted and what wasn't trusted. Because again, if you are broken into, if that did happen to us, we really want to be able to figure out what files were impacted. We created 7 accounts on the box. Of course, the guest account was disabled. We renamed the administrator account. And there's always arguments about, well, do you rename the administrator account? Is it useful? Is it not useful? The reason that we renamed the administrator account is it's very entertaining to watch people try to break into your box using the administrator account that actually doesn't exist anymore. And we created a new administrator account with strong passwords. We created accounts for the 2 people managing the site, and we created 2 just simple dummy accounts that had, I think, server operator privileges on the boxes. And we assigned random long passwords to these accounts. Now, which brings us to another point for those of you using Windows 2000 that you may or may not be aware of, and that's that Windows 2000 supports very long passwords. Supports passwords up to 127 characters, which is certainly nicer than the 14 characters that you had in NT4 and previous. So we actually used 16 character passwords for these accounts, and we generated them using a cryptographic random number generator, which is not necessarily what you do for everyday users. But the reason this is important is for those of you who are doing like service account management or other things, certainly don't leave your service accounts with 14 or 10 or 5 character passwords. Use 127 character passwords for your service account. Nobody has to remember it. It's not that bad of a deal. And it certainly makes sure that nobody will ever be able to brute force it. The other thing that happens when you generate passwords longer than 14 characters is no LAN manager hash is ever created for that password and stored in the box. Well, that has some negative effects too, like nobody can log in from a Windows 95 client, but people can log in from NT clients. But it also is interesting for some people in the room. Now, in terms of managing, we wanted to try to give people maybe a little bit of an advantage. And so instead of managing the site through the interior interface, we actually managed it through the internet. And instead of having to remember these long passwords that we've assigned to these administrative users, we simply used certificate mapping capabilities in IIS and gave certificates to the two site administrators who would use those certificates to authenticate against the site. Again, much easier than remembering these big, long, complicated, randomly generated passwords. And we enabled strong password policies on the machine. We talk about that. And for the Telnet server, we configured the Telnet server to require NTLM authentication. And we didn't do much with the Telnet server. We didn't use it a whole lot, but we did Telnet to it occasionally from across the internet. If anybody was watching, if anybody got a sniffer in, they would then have to break the NTLM v2 authentication that we used to authenticate to that to Telnet, which is certainly better than clear text password Telnet. We also sprinkled throughout the site some hidden tokens for people to find. So if in fact they had been able to gain access to the site and be able to pull data, at the top of the default.asp and comment.asp, which are two parts, two of the core ASPs on the site, we added a comment, which is effectively, if you're reading this, please send mail to us, and there's an email address with details of how you got here. So if you had in fact been able to read our ASP files, this would be the very first thing you would see. Similarly, we also had files stuck throughout the file system called like hi, I broke in.txt with a similar message, so that if you actually did break in and were able to browse our file system and obtain files that were ACLed against you, you would pretty easily find these files and then be able to report them. Similarly, we had stuff sprinkled through the SQL databases. If you had actually been able to break into the SQL server in the back end, you would have found similar comments. And if you would have returned them to me, I would have personally, since legally we couldn't give you anything, I would have personally given you a very nice prize. Now, we had some interesting but unsuccessful attacks, which are worth pointing out just to demonstrate some real good creativity on people's parts. We had somebody who spent about a week trying to do password guessing against our FTP server. Since we had FTP published, people could connect to the FTP server and they could issue commands to it. And we had a guy run, I assume it's a guy, and in a moment you'll know why I assume it's a guy, run a password guessing routine against our FTP server. And every few connections that he got it wrong, we'd terminate, and he'd reconnect, and he'd try to guess a few more, and he'd terminate and reconnect. And instead of trying to brute force passwords, he was trying to brute force names with 3 known passwords, which were password, client, and data. He was trying to find a name of somebody who had those passwords. Well, the interesting thing is he thought that he only used male names. There were no female names anywhere in anything that he tried, which was kind of interesting to if you're an observer of human behavior. The other one is we had a guy who ran for 2 weeks, a brute force attack, trying to guess the administrator password. The only problem is this poor guy misspelled administrator in trying to brute force, and he spelled it administrator with only one R at the end. And while we kind of wanted to get, actually, if you read the comments on the website that we posted, there was a hint that said, and by the way, something about, by the way, you have to spell the account name right in order to get the password. And the attack went on for quite some time, so it was a little curious. But one of the big, places that people tried to get into was the FTP site. People tried every single FTP command they could. They tried to pump various lanes of stuff into the various parameters of the commands. So people did a good job exercising the FTP server. People also tried to guess the vroot names on IIS. We only had a couple of vroots, but they wanted to find out if we had other vroots, and so people went through and they went through the entire dictionary of every possible vroot name that was a dictionary word, and of course that yielded nothing. And we even had people trying to attack us using non-NT exploits. So we had a few Linux-specific exploits. We had somebody trying to stuff. So anyway, some fun exploits into the system that were not applicable to our platform. But I guess they assumed that maybe we really weren't running Windows 2000 on this box, and they were going to just check or something. And so, but not to downplay any of that. The net result of this 10 gigabytes worth of log files and 10 10 million hits and 500,000 attacks, is that we found a few bugs. And the vast majority were actually memory leak bugs that would take, potentially a week or 2 weeks or 3 weeks to be able to exploit under a lot of conditions. But again, because we have these assert commands in the debugger with the debugger attached, it barfed pretty quickly. Excuse the term, but that's basically what it did. One of which was a queuing problem in the TCP stack that had been introduced. We found that was actually one of the first ones within a few days because people were exercising the stack pretty well. Memory leaks, page pool memory leaks that would grind the system to a halt and effectively run out of page pool, non-page pool memory, which was ugly. And one of the major things that we were able to improve through this was resilience to SYN attacks, because we saw weeks worth of SYN attacks like you've never seen before, and we just sat there and we analyzed them, and we analyzed how much we slowed down when under a SYN attack and what happened and how quickly we recovered, and we were able to make that better. So Windows 2000 now recovers significantly faster when a SYN attack stops, and it doesn't consume nearly as much CPU time while it's under a SYN attack. Now the reality is, in a real world, SYN attacks are a fundamental problem that we have to deal with. There's no silver bullet for dealing with them, but you can certainly block given IP addresses. If the SYN attack is coming from a specific IP address, you can block those at the firewalls. And the nice thing about SYN attacks is that basically when they do stop, the system does return to normal. And so you'll see there's a few more here. One of the other things that we had done is, since we were using netmon so heavily, we quickly discovered that there was a limitation the netmon guys had built. They figured that nobody was ever going to capture more than a gigabyte of netmon data at a time. And we kind of really demonstrated to them that they're wrong. And so they upped that limit significantly, so we were able to capture the whole 8 gigabytes a day and not have to keep stopping netmon every 3 hours and dumping the netmon database. So while not a vulnerability, it still helped to definitely improve the tools in the product. There's a problem in the perf mount counters in IIS that you could, by sending certain crafted attacks to IIS, you would create a memory leak in the perfmon counters, and effectively what that would result in is you got zeros for all the results of all your perfmon counters. So if you were using perfmon counters for important data, statistics collection or whatever, you wouldn't be able to do that if somebody subjected you to that attack. So we're able to fix those counters, and we're able to fix a memory leak in LDAP as well that was discovered through the testing on that site. Now, there are other, kinds of wonderful creative things that happened. The first bullet item up here is one that people always chuckle about, and they talk about conspiracies this and conspiracies that. But I tell you, in August, at the beginning of August last year, we had one killer electrical storm. And you can always check with the National Weather Service if you even care, but it wiped out our communication lines, like on the third day of this site. And the rest of these actually just demonstrate tried and true policy and administration things. Our ISP, an offsite ISP, the first thing that happened is after people were bored with our site the first few days, they started going after the routers, down 1, down 2, down 3, in terms of the number of hops. And they found that one of the routers, two downlink from us still had a default installation password, and so they took over that router and did some fun things with the router for a while until we figured out what was going on. The first way we realized it is we were suddenly getting no traffic anymore, and we were kind of scratching our head and going, people got bored awfully quick, and then we went out to the internet and through a different tap, and we tried to ping ourselves, and of course there's nothing there, and we tried traceroute and basically died at a router, and people were redirecting it across the world. And so we were able to contact the ISP, and they were able to go in and take control of the router, reflash it, and set a password. Then we had another one with the router firmware being out of date on the router immediately upstream from us that fed directly into us from our T1. having an out-of-date version of firmware, and people were creative. It was basically an out-of-the-box, you go and you bought a Cisco router, you just stick it into the wall, you don't look at the date, the fact that it was manufactured a year ago, and you just let it start running, and that's effectively what happened. And somebody wiped that router out and kept taking it down until we figured that out, went to Cisco's site, downloaded their iOS update and patched it. Again, the next bullet is really, stupid administrator tricks, because these boxes were effectively sitting in somebody's locked office. He had a rack of machines sitting there right in front of him, and without realizing it, he shut off the debugger box that the SQL Server was attached to. And when you shut off the debugger, certainly the Microsoft debugger comes with Visual C, the process that you're connected to dies, and if the process is the operating system dies. So the SQL Server was down for a while, and people were starting to send us email about, hey, your guestbook app doesn't work anymore, and we're like scratching our head a little bit and trying to figure out what happened. It was the debugger was off. Not a whole lot of other stuff. The ones, 3 from the bottom, because we're dealing with daily builds of the Windows operating system, many people here probably aren't familiar with how we build it, but effectively we have a centralized build process where developers check code in. It goes to a centralized build. They check code diffs in, goes to a centralized area. The centralized area reviews the code, checks to make sure they're approved to check it in. They check it in, and they build a version of the OS. And then people run that version of the OS, and so we live from day to day on the stuff that we build. So if the stuff that we build is crap, then we live on crap. So we're very incented to build better stuff because we won't be able to get our job done. But in this case, we had actually taken a direct drop from the TCP developers of an update to the TCP stack that had a debug breakpoint that he was trying to fix some other performance problem, and he had put a debug breakpoint into his private build. And we took that private build, not realizing it was a debug breakpoint. So as soon as the first SYN attack came back in, we dropped into a debugger again. And so these, various kinds of things. The other problem that we had was people just massive posting to the ASP pages. The reality is the more data you pump into an ASP page, the machine's got to process that information. And so we had people just constantly feeding information into the ASP parser. And finally, the final stupid admin trick was really one of my colleagues said the administrator lockout or the account lockout to 3 failed login attempts. And once we enabled the FTP server and people started really doing password guessing attacks, they locked out a couple of the accounts, including the account that the FTP server and the web server ran under. Now the good news is while those processes are running, if the account gets locked out, that's not a problem. They continue to run. But the next time you reboot the machine, they don't start up again. And then you sit there and you scratch your head and you go, well, why didn't the service start? And then you start doing your tracing and you find out, well, the accounts are locked out. Which, again, there's a lesson learned there about, security versus survivability of the system. And that account lockout on an account used on an internet host should be set differently than something on like a corporate network asset or something. So just to give you a feel for the way that we responded to these attacks, effectively attacks came in 3 classes. One was there's really a bug in Windows, and we go and we grab the developer and the tester by the hair, and we drag them up to the office, and we pop them down in front of the machine, and we say, you're not leaving until you fix this. Which is not something that many of you have the luxury of being able to do. So hopefully we're doing that on your behalf. But certainly in your case, you would be calling your support representative or so forth and grabbing them by the hair and dragging them out and making them fix it. There's a bug in our ASP code, which we fixed a number of these at the beginning. We simply went ahead and fixed it. But we had a lot of these IP, it's a fact of IP, right? It's the laws of IP. SYN attacks. And we had people that were just, spent their whole life trying to either IP frag us or SYN attack us, to the point where it got boring that real data couldn't come through. We would simply go into IPsec port filter and we'd say, this TCP address out here, just drop all of his packets from now on. And we would just leave it that way for a while to permit, more intelligent attacks to try to come through, things that we realized, at least had a possibility. So our top attacks on the site were listed up here. IP fragmentation was by far the weapon of choice across the entire roughly 3-month portion of time that this site was up. SYN floods were tremendous, and we had people that ran traceroute on us constantly, 24 hours a day, 7 days a week for 3 months. They just kept running traceroute, and you could see the ICMP packets come in, and you could just watch that they were doing traceroute. While it's not an attack, it actually constituted a lot of traffic. And those were people that wanted to, know immediately once our site went down, so they could go, say, the Windows 2000 test.com site's down again. People are very creative with their IP protocol attacks in terms of going through every possible parameter they could, using a lot of interesting tricks. While we didn't come up with any other interesting bugs out of what I said, we were able to kind of look at the data from the creativity of the attack and optimize a little bit about how we actually handle things in the stack, such that we can weed out the attacks even earlier, thus improving overall performance when under attack. IP half scans were, for some reason, very popular. I guess somebody just learned how to do those in school or something at that point. FTP was huge. People tried RDS attacks against us. The color dollar data against the web servers, and all the various dot attacks against IIS represented a lot of our log files. Huge URLs that people would shove through at us and so forth. But the most interesting part is that we had a lot of very coordinated attacks. They weren't attacks that were coming from one source. They were attacks that were coming from many sources at the same time, trying to take advantage of perhaps timing issues or so forth. So there was a lot of creativity and coordination that went on there. From a recommendations point of view, one of the interesting things that happened to us is we say that we went live on August 3rd. That's because we physically plugged the box into the internet outlet on August 3rd. We never announced this site to anyone, ever. Somebody just found it a few minutes after we installed it. In general, people watch our sites very closely when we register DNS names, and then they ping them constantly. And we got a lot of, if you were here for Dave LeBlanc's talk earlier, he mentioned something like 10,000 attacks per hour against our internet-facing presence, which we suddenly became a part of. So we were found very, very, very quickly. So the recommendation here is make sure you are hardened before you connect to the internet. Don't assume that because you're not live, you're not published, you're not anything else, people won't find you, because people will port scan you. I get it all the time at home on my DSL connections. People will find you. And if you've waited to set your admin account, or you've waited to turn off certain services, you may have waited too long. Secondly, stress test your boxes before you put them online, and make sure that you really do have good components. We did something that, in an IT organization would not have been prudent, which is putting workstation class boxes without RAID arrays, without UPSs, without all the kinds of things you may want, without redundant power supplies and so forth, and put them in server roles. Well, one of the interesting things that caused us is we had a bug check in audio drivers once when we upgraded from one daily build to the next. There was a bug in that version of one of the audio drivers that we happened to have in that box. And so it took us 8 hours to get that box back up because we had to revert back to the previous day's build. And so, why did we have an audio driver on a server? I'm not quite sure yet, but make sure that the components that are in these boxes are well stress tested and that you understand them. And that when you are replacing components in these boxes, make sure that the components are equivalent or are tested. Because when you go from one Adaptec SCSI controller to another, or one 3Com network card to another, there are different characteristics on those cards. There are different performance characteristics and so forth. So don't take that lightly. We did what you should never ever do, which is not put a firewall in front of an internet-connected site. If you have an important internet-connected site, you should absolutely be putting firewalls, filtering devices. You should take every advantage that you possibly can against the people out there who want to take advantage of you. And what that means is, putting everything you can. Just because you have a firewall, just because you have a filtering router, doesn't mean you shouldn't also run this wonderful IPsec port filtering stuff. Run it in conjunction. Do as much as you possibly can. We have a configurable SYN flooding optimization in NT. It's not enabled in a default install, but it's enabled on a default web server install. But if you're web-facing, you want to set your SYN optimization flag such that you'll be optimized for performance under SYN attacks. Out of all of what we learned out of this, we built the IIS-5 security configuration checklist, which is everything that we went through to make this site work, including the IP config stuff, including what settings to change, and then we built a security configuration manager template that you can use to actually simply put on your web server and apply that policy template to your web server using the security configuration toolsets in Windows 2000. And then you get all of the registry settings, all the file system controls, all of the registry ACLs, and everything else that we used on this site. And it's all documented in that configuration guide as well. Definitely work with your ISP to make sure that their upstream stuff is secure, that they're keeping track of patches, that they're and that they in fact have passwords on their routers. Very good thing to do. Monitor your logs regularly. You can definitely see all of these kinds of attacks coming through on various logs. You can see RDS attacks coming on IIS logs. If people are trying to guess passwords or break into other stuff, you can see that actually happen on the logs. So make sure you look at your logs on a regular basis, and that you have people that really that are trained to know what to look for in those logs. Close down unneeded ports, turn off unneeded services. Can't say enough about that. Use strong passwords, use long passwords, use certificates. Definitely, if you're administering your IIS boxes, use certificates for the administration process. It's a very, very easy step to do. You can use the certificate server built into Windows 2000 to issue the certificates. You don't have to go buy them from somebody. Just use them to administer the site in a more secure fashion. So, I often get people to say, well, the site wouldn't have stayed up for so long, or the site wouldn't have been so successful, or you would have found more bugs if I had a shot at it. And I get a lot of that. And your turn is next. You can come. We're going to put another one of these up for the next version of Windows. So me and my colleagues are currently working on a plan to put a new site up, to do a better job, to put more fun targets up there, and to sit down with legal again and figure out what kind of prize we might be able to finally offer, now that we have a little longer leadway with them. But you can try your hand at it in a few months. And the other interesting thing is, if some of you folks haven't seen, recently, I think 2 days ago, eWeek shut their site down finally, the end of the tournament, but they had a site up for a while, which was a kind of interesting mix of heterogeneous platforms, Solaris box running Oracle and Linux and some other boxes, 2 Windows 2000 boxes, all running on kind of a real built application that really mimicked a real customer site. And they had it up there for a number of weeks, and they had some attacks and some exploits, and I'm happy to say that the Windows 2000 server running Exchange for SMTP email services had no problems and was never compromised and never taken down, and that the domain controller was serving LDAP functionality for the site, the Windows 2000 domain controller never had a hiccup as well. But it's an interesting reading if you go take a look at eWeek and see what they did. And they'll also be publishing information about how they built that site and so forth. So some additional resources. In the next week or so, we'll actually have a white paper written about basically the talk that I've just given with additional filled-in information, with some configuration settings, with some statistics and graphs and so forth about the Windows2000test.com site. It'll be on Microsoft.com/security, and you can take a look at that and can get a feel for what happened and how to apply some of that to your site. The IS5 security configuration checklist, a very important thing, and the configuration tool are both available today on Microsoft.com/security. And I'm happy to announce that my colleague in crime, Michael Howard, as of 2 weeks ago, a new book is available called Designing Secure Web-Based Applications for Windows 2000, which actually also documents an enormous wealth of stuff that Mike has learned over the past year and for his last couple of years as the security program manager of the IIS product. So a terrific book, again, for information about how to defend and secure not only your site, but to build applications that are robust and securable on the internet. So with that, thank you very much for your time, and we'll have some time for a couple of questions. Anyone?